Should we be worried about the singularity?
Should we be worried about the singularity? Okay. Oh boy, this gets me into all kinds of interesting. So first question is, we have to look at what the likely future of artificial intelligence and all these kinds of things is, and I think we can see lots of trends right now. We can ask questions. Are we all going to be eaten by AIs? These kinds of things. I think the story of technology has been sort of a story of how do we automate things that humans do? How do we take, and ultimately, what does technology do? What technology should do is to take what humans want to do and have it happen automatically. And that's what we try to do with Wolfram Language and with our technology stack, is have the humans tell us what they want to do. That's what Wolfram Language is about. Then we'll go figure out how best to do that. So in a sense, as AI gets better, as our capabilities in these directions get better, we will get better at automating the execution of kind of human goals. One of the issues that's sort of interesting is, how do you describe your goals? How do you describe what you want to do to a system? And we've got kind of two answers to that. One is in Wolfram Alpha, you use pure human natural language. The other is in Wolfram Language, where you're using a precise specification language. It's sort of interesting to me to think about what kinds of things can you just describe in pure natural language, what kinds of things do you need a more structured language to describe. It's kind of interesting in writing this little book about Wolfram Language that I've been doing, and I've been trying to write exercises and things for this book. And as I get later and later in the book, so people sort of presumably know more about Wolfram Language, and I'm writing these exercises, I'm realizing there's something incredibly goofy about what I'm doing. I'm trying to describe in English something which is actually a fairly short program. And I'm writing these several sentence English things, and then I see, and the program this corresponds to is this really short thing that's pretty easy to understand. So this is a case where natural language is not the most efficient way to interact. Okay, so with respect to kind of AIs, I tend to think, so first thing to understand is, let's talk about what technology can do. I mean, so technology. Okay, so I believe there is a certain scenario in which the machines, in a sense, take over, but in a rather strange way. When we drive around with cars with GPSs and so on, most of us, like me, for example, they just plug in an address and the GPS tells them where to go, and then we just drive wherever the GPS tells us to go. Increasingly, systems will be able to predict what we should do based on our sort of stated goal or whatever. Systems will predict we should do this, we should do that. You're talking to this person, this person has these interests which overlap with yours. You should raise this point in the conversation, et cetera, et cetera, et cetera. All these kinds of things. And I think that the likely scenario in the fairly near term is, there's enough kind of auto-suggestion from the machines that most humans, most of the time, are just doing what their machines are suggesting to them to do. So that's in some sense, that's the kind of, then the machines are in charge in some sense, although it's only by the choice of the people that they're doing that. But I think more generally, one of the questions is, imagine that you have sort of the infinitely smart machine and it's sitting in a box on your desk. Well, I should explain another point. Okay, so there's this question about what, sort of scales of computation and scales of intelligence and so on. Well, I used to believe that there was sort of that there were things that were just computation, and then there were things that were intelligence. I used to assume that there was kind of a bright line distinction between the merely computational and the actually intelligent, so to speak. Then I spent a bunch of years working on my big new kind of science effort, and I realized that that was just not true. That in fact, there is, when we look at different computational systems, there's a certain threshold that's reached that we can start seeing in things like the phenomenon of universal computation and so on. And above that threshold, basically all systems are equivalent in the computations they can do. So kind of the funny version of that is things like, the weather has a mind of its own. What does that mean? Well, that actually has some sort of scientific meaning, because these fluid dynamics in the atmosphere and so on is doing a computation just like things in our brains are doing a computation. The question is, can we say our brains are just dramatically much better than the fluid in the atmosphere? And the answer is no. They're both doing sort of an irreducible amount of computation. Throughout in lots of different places in nature and elsewhere, and in little programs that we can construct, we're able to make things which sort of have as sophisticated computation as any other thing. And that has all kinds of consequences about making models in science and all sorts of other things. But one consequence it has is that one no longer feels, I don't think one can feel sort of that the human intelligence thing is special relative to what's possible in computation elsewhere. So this kind of philosophical realization was actually the thing that caused me to actually launch into trying to do the Wolfram Alpha project about, whatever it was, 12 years ago or something now. Because I had always assumed, I'd kind of thought about doing things like Wolfram Alpha for 20 years before that, but I'd always assumed that to build a Wolfram Alpha, to build a knowledge engine that could deal with lots of computable knowledge in the world, that one would have to have a human brain-like thing, and that would be, and that one sort of had to one had to do something that emulated a brain. And then I realized from the work on NKS that basically it's all just computation. There's no sharp distinction between the intelligent and the merely computational. So anyway, that then the question is, okay, so you end up with the AI box on your desk, and it's doing all this sophisticated computation inside. The big problem for an AI box is, well, it can do this computation. The computation it does is equivalent to a brain. It's equivalent to lots of systems in nature. The question is, what does it choose to do? And the thing is that while the one feature of what we end up doing that there's no sort of theoretical sense of the box must have these goals. The box, there's no abstract way of defining goals for things. Goals are things that arise for humans from sort of a long history of cultural history, individual history, biology, et cetera, et cetera, et cetera. So I think that it's sort of a nonsense to imagine that there's this AI that is just doing its own thing. It's something where ultimately lots of things do computation, but to have for the thing to have goals, goals are a very human kind of thing. So anyway, there's that sort of thing. I think that oh gosh, there's so much to say about this. I've thought a whole bunch about this, and maybe, another thing that's sort of interesting is as we look at kind of the emergence of things that used to be pure human ability, like, for example, things like image recognition. That used to be something humans found easy, but computers find it really hard. Well, now it turns out we've managed to get to the point where computers find it pretty easy as well. One thing that's interesting is the reason that computers find it easy now is because with our CPUs and GPUs and so on, we've reached a scale that is somewhat comparable to the scale of human visual processing, to the scale of what we do in our own brains for visual processing. And I think that and so that's why kind of we're impressed now because our machines can identify 10,000 kinds of objects, which is about the same as what we can identify. So then the question comes, well, what happens when the machines get bigger, which they inevitably will, and they can identify 1 million kinds of objects, far beyond what we can do? How do we think about that? What's going on? And one of the things to realize is that the machine kind of so the thing that we have to communicate kind of when we have sort of thoughts, the way we get to communicate them is with natural language. I should say that I sort of view there as being some kind of hierarchy, and I don't fully understand this, so I'm not going to be totally coherent on this, but there's sort of a hierarchy of communication mechanisms that exist in the world, so to speak. So the sort of the lowest level is you're an organism and you're going to have progeny, and there's sort of communication from you to your progeny because you have shared genetics, and certain information is communicated by the fact that by genetics, basically. The next level of communication, so to speak, is the kind of thing that happens in things like visual object recognition, where at every generation there's a fresh brain, and that brain is exposed to the world, and that brain learns object recognition, for example. Well, then the next thing, which was sort of the big innovation of a few 100,000 years ago of our species, was this idea of natural language, the idea that you could go from one brain through natural language to communicate pure thoughts to another brain. And that's kind of the big innovation led to human civilization and all kinds of other good things. So the thing that I'm wondering, and I don't understand it yet, is okay, now we have a different form of communication. So one disadvantage of natural language is, I tell you something And I've got a well-formed thought in my brain, but to communicate it to you, I have to go through natural language. You have to absorb the thing. You have to turn that into a thought in your brain. It's all kind of inefficient. By the time we have a knowledge-based language, computer language, that can describe the same kinds of things as natural language can describe, that can talk about the real world and so on, but it doesn't have this feature that it has to be reabsorbed by another brain. It's something where the language itself precisely defines what to do. You can just send it to any interpreter of the language and it can immediately execute it. So you have a sort of a closer form of communication than is possible by any of these other sort of levels in this hierarchy. And I don't understand what the consequences of this are, but I think they may be rather significant. And I think that this raises questions like when a large fraction of people in the world know how to program, what consequences does that have? What kinds of new forms of organization become possible? Things like that. But another thing that I've realized is that we talk about human natural language as a way that we communicate and we reason about the world and so on. One of the things that's a little bit troubling to me is when I think about these big sort of AI systems that recognize a million different kinds of objects and so on, inside that system, it is making distinctions. It's deciding. So you look at the low levels in visual processing for something like our image identify function, it is identifying things that correspond to vertical stripes, horizontal stripes, blobs, other such things. Things that are actually very similar to the human primary visual cortex, and things for which we as humans have pretty good names. We say it's vertical stuff, it's horizontal stuff, things like this. As you go to higher levels in the system, it is making distinctions. It's deciding, it's playing some analog of 20 questions or something effectively. It's deciding, animal, vegetable, mineral, whatever it is. It's making a distinction. This class of things are distinguished by the fact that they have weird crinkled boundaries that have these characteristics and so on, something that we, whereas these things have a different form. It's making distinctions, but we don't have words for those distinctions. We have words for some of the lower level distinctions. We don't have words for these intermediate distinctions. Yet, in one of these systems, these words can be very useful in making distinctions, so to speak. So they're things for which we could have words, but the actual evolution of our species and our language and so on has not given us words for those things. And so I have this sort of crazy, pretentious name that I came up with for this as post-linguistic emergent concepts, or PLEX, for these kinds of things that are sort of the emergent ideas that essentially AIs will have that allow them to distinguish things about the world. So one scenario that I have to say I'm slightly curious about is, there may be that there are lots of these distinctions that can be made, and when you start learning things in much bigger systems, there will be these kind of plex that the systems use to make distinctions between things, and in a sense there'll be a sort of a big dialogue of plex among the AIs that us humans simply won't understand. I mean, in other words, our language advances at a certain rate. We add a certain number of words that deal with certain distinctions we didn't have before. There are plenty of things we talk about in technology now that we weren't able to talk about before. But our language advances at a quite slow rate. And the question is, when it comes to, will we understand what happens in any of these systems? Well, the answer is ultimately no, we won't understand it. But that's actually nothing new. Because when we look at nature, there are all sorts of things that happen in nature that we don't understand. We can have little pieces of what's going on we can describe using simple physical laws and things like this. But a lot of what goes on we can't understand, and in fact, we even, for theoretical reasons, we expect that there'll be sort of computational irreducibility, that we'll have to actually simulate each step in order to find out what happens. So anyway, a few thoughts about. I have to say, okay, I'll say one last. This is the kind of thing I like to think about. There's several other things. I mean, one thing I've been interested in is how do we take sort of human natural language and, so in Wolfram language, we've tried to formalize talking about lots of kinds of things in the world. But we haven't fully formalized kind of everyday discourse about things. It's actually important to formalize that kind of everyday discourse because it's how people want to talk to their cars and thermostats and other kinds of things like that. There's more kinds of discourse that we have to be able to deal with. And so I've been interested in how do we so for example, we have, a predicate like, x is greater than 7. And so we say, there are other kinds of predicates that exist in human language, like, I like chocolate or something. That's in a sense a predicate. It's a different kind of predicate than x is greater than 7. But so I've been interested in kind of deconstructing the types of meaning that exist in everyday human language and everyday discourse, and trying to find formalizations of them in the same kind of way that we found formalizations in Wolfram language for lots of other things. And actually, that subject is kind of interesting because it has a long history, but mostly an ancient history. There was, particularly in the 1600s, there was a lot of work done on so-called philosophical languages. And it's kind of fun to look back at the works of there's a chap called John Wilkins, for example, who had a whole book about the philosophical language, which is kind of a formalization of everyday discourse at the time. And it's actually sort of satisfying in a way, because a lot has changed since the 1600s. There are a lot of kinds of things that were particularly about the brutality of life in the 1600s, so to speak. We can just get rid of that whole section, so to speak, of the kind of semantic framework. And there's also a lot of stuff which was just completely unknown in the 1600s, mostly to do with technology and so on, and also to some extent human organizations that can be added. My final comment on this, and the more that I could say about it, but there's final comment on this is one of the things that's a concern is you look at automating lots of kinds of things, and then you ask, well, what will the humans actually do? And all this stuff is automated. The fact is, in the next many kinds of activities that involve kind of manual labor and things like this have been automated in most parts of the world, a lot of kind of white-collar professional kinds of activities will get automated in the next decade or two, I suspect. And the question is, what do the humans do at that point? I would say the number one thing is the humans define the goals, because that's something that in some theoretical sense the machines can't do. But at some other sense, somewhat more cynically, you say, well, the humans just play video games, and maybe they play, they're back to the Middle Ages, so to speak, now playing video games about the Middle Ages that have been, and maybe in the future they're back to, playing video games about the 20th century or something. But then I realized, thinking about that, and it's like, oh, that sounds really terrible. But then you think about what somebody from 1,000 years ago would say about what we mostly do today. They would look at the activities that we pursue today, and they would say the equivalent of, those look like playing a bunch of video games. These are very meaningful activities to us now, but from the point of view of 1,000 years ago, when there were a lot of very much more practical issues about growing your food and all these kinds of things, the things we do now seem like kind of frivolous video game-like activities. So I think that we can expect, to think of the same kind of thing is going to happen again, although to the people of the time, so to speak, those activities will seem perfectly meaningful. There's all kinds of other things to say about future of, lots of other things to say. But okay, let me not spend the whole time talking about this one topic. But thank you for that question. Yes.